Okay, hi everyone. I'm going to go over the test 3 review questions. I'm going to kind of do a speed run, and I'm going to try to be as thorough as possible as I go through it. So the first question says, simplify, enter the results as one single log with a coefficient of 1. So here we go. So we're going to rewrite this as something like a log that looks like this, just one log. So if you remember, if we're subtracting logs, we're actually dividing on the inside. So we can rewrite that log base 3 of 8x cubed on top divided by 11x to the 9 on bottom. We can reduce this because we have x cubed on top, x on the bottom. So this would reduce down to log base 3, 8 on top, 11 on bottom, and only 6 left, x to 6 left. Sorry, that's an exponent position. Okay. All right. Next question is we're going to take our squished up log and we're going to break it up into sum and difference logs with no exponents. All these exponents have to come down. So as a reminder, if you're multiplying, you're adding, and if you're dividing, you're subtracting. So let's go ahead and separate that. It's going to be log x to the 19th plus log y to the 4th minus log z to the 10th. Then we're going to take the exponents and move them to the front. So it's going to be 19 log of x plus 4 log of y minus 10 log of z. Yep. Our next one is the same type of problem, except they want you to enter it a little differently. What happens to our exponents going down? What happens to those exponents? And so if we rewrite this as log of x squared plus log of y 20 minus log of z to the 18th power, the exponents coming down, we end up with 2 log of x plus 20 log of y minus 18 log of z. So our a value corresponding to the first term would be 2. Our b term corresponding to the y value would be 20. And our c term corresponding to the z would be negative 18. Okay, next one, simplify the following into a single logarithm. Again, if we're subtracting, we're dividing, and what happens to these coefficients in the front? Where do they really belong? They belong in exponents, right? So if we rewrite this as 3 log of 7 minus 2 log of x, the 3 goes up and the 2 goes up, log 7 cubed minus log x squared, and if we're subtracting, we're really dividing, log 7 cubed over x squared. To write that as one log. Simplify the following to write this as a single log, one similar to what we just did before. Log 5 log 2 plus 3 log x. The 2 goes up, the 3 goes up, log of 2 to the 5th plus log of x cubed. Now that we have the logs that are adding to each other, now we can write this as division problem. Log 2 to the 5th divided by x cubed. Sorry, up here, I meant. For m in the equation below, it may be helpful to convert the equation into exponential form. Write the answer as an integer or reduced fraction. Okay, so they want us to rewrite this problem to solve for m. So two different ways. Remember, we can write either the identity or we can use algebra. Log base 8, m is equal to 2. We can write 8 to both sides. That gets rid of the log base 8. M is equal to 8 squared. We're going to do circle of logs. Log base 8, m equals to 2. 2 to the second power is m. 8 squared is equal to m. And 8 squared is 64. Okay, we're solving logs again. Log base 2 of 7x plus 4 equals 1. So we can do the circle of logs like we just did in the last problem, or let's do our solving algebraically using our exponents. So 2 is our base. So this cancels out. We have 7x plus 4 is equal to 2 to the 1 is just 2. 7x plus 4 is equal to 2 minus 4 minus 4. 7x equals to negative 2 divided by 7. X is equal to negative 2 over 7. Okay. if we want to do circle of logs, we could say log base 2 of 7 plus 7x plus 4 equals to 1. 2 to the first equals to 7x plus 4. Then we minus the 4 and divide the 7, we get the same answer. Okay, our next problem is solving for x here. So you can see that we're trying to figure out what the exponent would be, x. So I'm going to say log, sorry, let's write out first. 2 to the x equals to 35. Now, to solve for exponents, we need to log both sides. So I'm going to use log base 2 of 2 to the x equals to log base 2 of 35. The reason why I chose 2, because 2 is going to get rid of this base here. So we're left with just x is equal to log base 2 of 35. We don't know how many 2's become 35, so we will have to use our calculator. Let's see if I have my calculator. Oh no, don't go away. Yes, I got rid of it. Oh no, I did save it this time. So you would have to type your calculator onto your calculator. Using a calculator, log base 2 of 35 is equal to log of 35 over log of 2. Change the base. Okay, so plug that in your calculator and that'll give the answer there. I'm afraid that if I get out of this, it's going to mess up and erase it. Okay, so next one, e to the 7x equals to 14. So to solve for this exponent here, we're going to use our special log here for e's. That's natural log to 7x equals the natural log of 14. And that's our inverse to our base of e. Those cancel out, leaving me 7x equals to ln of 14. We can, as we practice this in class, we're going to type this in our calculator, and then we're going to divide this by 7. So x is equal to ln of 14 all over 7. Not 14 divided by 7, the natural log of 14 divided by 7. And that'll be answer here. Okay, the next problem is we're looking at it. I see we have two logs, so the only way for us to solve it is if we bring those logs together. So we're going to say log of x plus 4 minus x plus 3 is, if I'm subtracting logs, I'm dividing inside x plus 4 over x plus 3 is equal to 1. Now we can get rid of the log by, what's my base? What's the invisible base here? Invisible base is what is called a common log, so base 10 to both sides. So we have x plus 4 over x plus 3 is equal to 10 to the 1 is just 10. I'm going to multiply it on both sides. X plus 4 is equal to 10 times x plus 3. Let's go and distribute that. X plus 4 is equal to 10x plus 30. I'm going to move the x's over to my right. That's 4. And then I'm going to move the 30 to my left. 4 minus 30 is equal to 10x minus x. We're left with negative 26. Sorry, running out of space. Let's do it up here. Negative 26 is equal to 9x. So 9 is, divide 9 to both sides. X is equal to negative 26 over 9. Okay, similar problem right here. Let's go ahead and combine those. I see a plus sign, so we're going to write this log as log of x times x plus 2 equals to 6. We're going to combine that log to be log of x squared plus 2x equals to 6. We're going to get rid of this using common log. So since this is a common log, base 10 to both sides. X squared plus 2x equals to 10 to the 6 is a huge number here. 10 to 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. I need one more 0. Okay. And then to solve this one, we're going to use quadratic formula. X squared plus 2x minus 1, 2, 3, 4, 5, 6. And then we'll have to use the quadratic formula. X equals to negative b plus and minus square root of b squared minus 4ac all over 2a. So this one came out to be a kind of a big problem there. So x equals to negative 2 plus and minus square root of 2 squared minus 4 times 1 times 1 million all over, oh, negative 1 million. I don't know why I wrote in, yeah, negative 1 million all over 2a, which is 2. And that's just me, some calculator answer. Evaluate using your calculator, giving at least 3 decimal places. What's a log of 220? So on your calculator, you should have a log. Now remember, since it doesn't say anything, this is common log, so you're going to look at log base 10. And that's it, that's just calculator answer. Next problem here, I see a bunch of logs everywhere. Natural log x plus natural log x minus 7 equals to natural log 2x. Now, we can't just get rid of natural logs because we have a bunch of them on every side. We have to first combine it. So we can combine it. Natural log of x minus 7 equals to natural log 2x. Now we can get rid of the natural log. You had to combine them first before we can get rid of the natural logs. Now we're left with x minus 7 is equal to 2x. X squared minus 7x equals to 2x. We can subtract the 2x to both sides. X squared minus 9x equals to 0. And our answers here can be x is, factor out the x minus 9 is equal to 0. X could be 0 or 9. Okay. Now, let's check our answers. If can I put a 0 here? Would 0 be a possibility? Can we take the natural log of 0? E to what exponent would give me 0? And the answer is it doesn't exist, so there's no answer. So D and E. Meaning 0 is not a possibility, so only 9 is the answer here. Evaluate the following expression. Your answer must be the exact in the simplest form. Now this is just to practice, to say, hey, that the logs and exponents can cancel each other out. If you remember, natural log is log base e to negative 3, and these divide, so not divide, they cancel out, leaving you just a negative 3. E and natural log cancel out, leaving you just 4. E and natural log leave you a square root of 2. In this case, I would rewrite it because it doesn't look as obvious. So natural log e to the negative 5 power, to rewrite that, and then this simplifies out to become 1, and we're left with negative 5. Another way to remind yourself is log bring down exponents, so this would go to the in the front, and we'd have natural log of e, and this goes to 1. Write the expression in exponential form. They just want us to spin this around. Log base m of t is equal to a. Circle logs m to the a power is equal to, oops, sorry, wrong letter, is equal to t. Right, circle logs. Write this in exponential form. Okay, so jumping to exponentials, solving exponentials, a wooden artifact from an ancient tomb contains 25% of the carbon-14 that is present in living trees. How long ago to the nearest year was the artifact made? The half-life of carbon-14 is 5,730 years. Okay, a wooden artifact from an ancient tomb contains 25%. So when we're saying 25%, that means from 100%, after so many years we ended up with half of it, and then after so many years we ended up with half of that. Okay, so we went through one half-life period and then another half-life cycle. So one way for us to do this the easy way, since it is a nice 25%, is we say, hey, between how to get from 100 to 50%, we waited 5,730 years. And then to get from 50 to 25, we waited another 5,730 years. So how long ago to nearest year was the artifact made? It was made, if I can add these up, 10,000, 11,000, 460 years ago. And that's us just counting, since that's a nice percentage. If we really wanted to do it, we have a half-life equation that we can use. You can use 1/2 equals to e to the negative kt. That's what you learned in chemistry or physics, wherever. But the way I teach it is that if we start off with 100% and we ended up into 50%, how many years did that take us? E to the kt, that's 5,730. We would then solve it. 50 divided by 100 equals to e to the k 5730. This is just 1/2 equals to e k 5730. We're going to get rid of the e by natural log. So natural log ln of 1/2 is equal to k 5730. You're going to divide k to both 5730 to both sides. So it's natural log of 1/2. Calculator first, then divide that by 5730, and you end up with this k value. This k value should be negative. Once you find that k value, we can then plug it in, and we can say, how do you get from 100 to 25? E to the negative, or to the k value, which is the k value you're going to copy here, and you're going to solve for this t value. When we solve for this t value, the same exact steps that we did over here. Okay. Sorry, we're using my calculator, but I'm afraid I'm going to lose this. Okay, next one, find the logarithm. Okay, so in this case, we can do this without a calculator. So log base 4, the 4 on the bottom is going to be written as 4 to the negative 1 power. And if you remember, this cancels out. The long way to do it is logs bring down exponents. Negative 1, we have log base 4 of 4, and that equals to negative 1. Okay. That's negative 1. Okay, that's the end of part 1.